Hi everyone, how's it going? My name is Daryl. Welcome back to this series. In the last lessons, we just learned how to properly set up and create a notebook instance under the SageMaker environment. Now we are ready to work with this Jupyter notebook, build and train our predictions model. We will continue to be the chef. Let's get started. Let's move back to the SageMaker notebook. The first thing that we need to do is to create a S3 bucket. These buckets will help us to store the training data, the testing data, also the output artifact. So we need to create a S3 bucket. There are two ways that you can create that. You can just go to the console and type in S3 and go to S3 and create the bucket over here. On the other hand, is that you can use this Photo3, which is an Amazon Web Service that allows us to directly create, update, and delete AWS resources with the use of Python scripts. In that case, it would be much more easier for us to connect this bucket 3 directly within this notebook and also delete this bucket 3 when we do not need it anymore. So the first things that I would like to do is to import this Photo3 and then assign the resources that we would like to use. And right now, we would like to use the S3 resources. So in that case, Photo3.resource S3, and we will assign it as a S3. Now these variables will contain this S3 subject object. First things that we would like to do is to give this S3 bucket a name. Over here you can see we didn't have any. We do not have any buckets right here, but when we create a bucket, we definitely name. So we will assign a bucket's name for that. This is so-called the Yahoo Finance stock price. And then we will use a method called create bucket, and the bucket is supposed to these bucket names. And I will just put it under the try except, because sometimes we might not be able to create these buckets with some error. In that case, we would like to handle it with this except. So if there's any error, just let me know. So exception as E and return me the error if there's any. So now I run the cell and then run the cell and see the S3 bucket has been created successfully. Now, if I move back to this S3 management console, you will see the bucket has been created successfully over here. But of course, at this point, there's nothing inside. When we are assigning this bucket, sometimes there's some rules for the naming. So remember that, say for example, the bucket names must be the letters must be between 3 to 63 characters long. So and so, everything has to be started with a lower letters or numbers or so and so. And I'm not going to go through that. I will just leave it over here. On the other hand, is that you can go to the Amazon document, check the naming requirements. But sometimes it's so easy to have these assign the buckets a wrong name so that there's some error. Now we can create the training and also validation CSV. The first things that we would like to do is to install is to install the Yahoo Finance. And because this is the modules that we're going to use, but this is not a common module, so this is not be installed with the Amazon SageMaker environment. In that case, I'm going to install this Yahoo Finance, and on the other hand, I will also import the pandas, the datatimes as well. But for but they're commonly used, so they are ready here. The times that I'm going to the data that I'm going to extract is 2 years data. So everything will be in within 2019 to 2021. That is the start date and date. And then I will download the Apple, which is the stock price, which is the stock. This is the stock price that we would like to make a predictions on, and this and then we'll assign it in data frame. So everything will be inside a pandas data frame. Then we will just reset the index. Let me show you the data. Here we go. This is the data, raw data that we have. We have the date, we have the open price, we have the high price, the highest price of the day, lowest price of the day, we have closing price, we have the adjusted cost, and also we have the volume traded in the date. Now we are ready to extract, load, and transform the data after having these entire table for the raw data. So the next things that I would like to do is to drop 2 column. And what I'm going to do is to drop these adjusted codes and also the date, because they might not be useful in predicting the stock price of the asset. So in that case, I just drop them. And now, after dropping that, I would like to extract the features. So let me drop them first, and then I would like to extract the features. There's a typo over here. Wait. What I'm doing is that I would like to pick out this information, the previous date, the next day's stock price of Apple. So in that case, I would like to take out the last row. Just take out the last row, then all the rest will be our features. Now, on the other hand, I would like to skip the first row and only take out the open price as our target. Now, if I run the cell, our target. So let's have a quick check this. So for this one, this is the informations January 2nd. Then I would like to predict next day's stock price 35.99. So this is our target. Excellent. So now we can combine everything together and create our final data output. So what I've done here is that I just set these, assign these targets, and combine it with the features. For XGBoost to work, you need to assign the target columns in the first column. So in that case, I just rearrange these target columns and insert it back to this to this final table. And then now we got this final table. We have the target. We have all the features. Now we are ready to train, test, speed the data. So we are ready to do the train test speed. And I will just import the NumPy because it will help me to perform the random sampling. For each of the row, we'll take a sample. So this is the randomized sample. What I would like to do is to split it up, and 20% will be used for testing, and then 80% will be used for training. So just use the NumPy speed and use the put this. The first argument is this table, the data frames table, and then 80% of the data will be used for training. 20% will be for testing. Excellent. Now the data is ready. We can then set a path for the bucket, for the training CSV, and also for the testing CSV. We can set a path for the bucket. Then upload these two files over to this bucket. These will be our training data CSV file with our testing data in a CSV format. So this will be our preface, and then we will have our bucket name, here we go. This will be our bucket name, Yahoo Finance price. We already created this bucket. So we will create a folder that is so-called this XGBoost as a built-in algo. This is the folder name. Then inside this folder, there will be two additional folder. One is the training folder. The other one is the testing folder. The file is a train.csv, also test.csv, and contains these training data and testing data respectively. And this format, you can find it into this SageMaker Python SDK v2. I will also put reference over here, because this is standard format provided by Amazon. SDK. Remember that we are using the SDK version 2. Also follow along this document. Now let's back to this, models. So now we can create the training CSV path and testing CSV path. This will be the path, the S3 bucket. Like what I mentioned, the first elements will be the bucket's name. That will be our folder names. Other folders, there will be two folders, train text, CSV file for each, one CSV file for each folder. And now, and load the data into this into this path. It's just done. Now, if we go back to our S3 management console, go back to our bucket, you will see there will be a folder that we just create. Like what I mentioned, there will be a test folder, train folder, test folder, the the test folder. This is the train folder that we just create. Inside the test folder, there will be a test CSV. Then inside the train folder, there will be a train CSV. Remember that this is a standard format that required by the SageMaker Python SDK version 2. So with this path, later on we can pass these two files to the XGBoost models properly. So now we are ready to build the XGBoost model. The step 1 and step 2. In the step 1, remember that we create the S3 bucket, and in the step 2, we just load, transform, and also prepares the data, the corresponding file. Now we're ready to build the XGBoost model. There's two ways to do that under the SageMaker's XGBoost. So we can use XGBoost as a framework to build that, or we can use XGBoost as a built-in algorithms to do that. So it depends on your choice. Then follow the links that I provided before, and see there's two ways. There are two SDKs model for each of the methods. So if I would like to use the XGBoost as a framework and follow this SDK version 1 or 2. On the other hand, if I would like to use the XGBoost as a built-in algorithm, and use this SDK version 1 or SDK version 2. In our cases, we will use the XGBoost as a algorithm. And just like what I mentioned, there are more informations over the link. And what we're going to do is to use the XGBoost as a built-in algorithm. There are 4 libraries that I would like to import. Of course, we need to import the SageMaker. And we will, from this SageMaker, we'll import the HLIS. This is where we can get the container image. Then we will import the sections that will help us to kickstart the sections for the training. Also import the training input to help us to prepare for the training input provided to XG algorithm. Now, what I would like to do is to firstly find a XGBoost image URI and build XGBoost container. So here they provide the link. They provide different frameworks and algorithm image. So you can just find out the image that are suitable for your own application. And in my case, I will use 1.2.2 here. So just use this image URIS and then use the methods called retrieve. Tell them we're going to use the XGBoost, and that we need to provide the widget names because some of the methods are not available in some of the regions. So we just provide the method. We provide the algorithm over here, provide the widget names over here. And finally, we will provide the versions that we would like to use. That is 1.22. That is 1.22. Then to achieve this container image. So just in case the regions that you define this stupid notebook do not support just in case it does not support that algorithm, it will let you know there. But for this time, I'm using the US East. In that case, the SageMaker for these versions supports. So now we can set up the hyperparameter for this XGBoost algorithm. And there's 2 types of parameters that you can set. First type is the booster parameter, which is to help us to control the training process with the training during the XGBoost training. And then the learning task parameter is to allow us to set up the objective for the XGBoost. For further information, please feel free to follow these links over here. And I would highly recommend you to follow these Kaggle links because it provides a full guide on XGBoost hyperparameter tuning and setting. So there are lots of information over here. Please feel free to check it out. The hyperparameters that I'm going to set is that the maximum depth that will be 5, a 0.2, gamma 4, medium child rate 6, subsample 0.7. And then the objective over here, that is the regressions model squared error. And early stopping and runs, and number of runs 1000. So to initialize these hyperparameters, everything will be inside a dictionary. Once we are ready for these hyperparameters and also for the image, we can then set up output path when the model train the models, where the train the model will be saved. That is the artifacts that will be saved. So again, we will use our S3 bucket, and the bucket's names that is the bucket's name that we have, and the folder is the preface that we have. Finally, we will the output folder. So everything will be saved in this bucket name under these folders, under this output folder. And now we are ready to construct a SageMaker estimator that will cause the XGBoost containers that we just assigned. So inside this SageMaker estimators, which allow us to set up the hyperparameters over here. The first thing that we've just set up is the boost container image. And that is the hyperparameters that we have. Remember, we also need to give it a role, and that is the IAM roles that we very beginning set that up. So we have the execution role over here. You just need one instance, so instance times equals 1. The instance type we use ml.m4.large. There are different instance types under the SageMaker, so please feel free to check out the documentation of SageMaker to find the right instance types to solve your problems. Of course, if you have a bigger problems, lots of the data with larger types. On the other hand, if you smaller problems that you would like to tackle, pick a smaller type. And then you need to set up the volume size equals 5 GB. Here, the output path, already set that up. Output folder. And then we will set the spot instant equals to true. So if we set it equals to true, we need to set the train max time. This is an integer argument representing the amount of times that we are willing to wait for the spot infrastructures to be available. And then the final one is the maximum waiting time. That is the times for the timeout in second for the entire training. So by setting this use spot instant equals to true, it will allow us to save some monies during the training. It's because we can wait. So until there's some available instance, they will share with us and start training our models. We do not need to start this training right away. On the other hand, if you have some top urgent trainings that you would like to do, so you need to set it as a false. In that case, you will not use this spot instance. And so right after the training, you will know how much you have already saved. So let me show you later on. So let's run the cell. Then now we can define the data types and path to the training and validations data. Remember, we've already saved the training and testing data in the CSV files, so they are CSV typed. And then the training inputs that they will take out the informations, take out the inputs in the data is from this S3 S3 folder. Remember, there's the bucket name fix and also the train that is for the training input data. And for the testing input, we also use the same methods. But for these times, we will take it out from the testing data folder. So now if I run this cell, and finally, we are ready to execute the XGBoost training job. This is the estimate. I just use the estimate.fit and provide the training input, the testing input, a dictionary. So now let's see what happened. Excellent. Training has been done. Actually, we have been wait around, I guess, 2 to 3 minutes to this spot instance, because we are using spot instance. And the training, it doesn't take too long, around 1 minute that's done. And you can see that because we are using the spot instance, so the total saving is up to 60%. Therefore, if your task is not urgent, remember to use the spot instance. Otherwise, if your task is urgent, of course, please feel free to set it as false. In that case, AWS will just assign you an instance right away. Now let's go back to the S3 bucket, because the model artifact after all this training will be your output path. So will be in this S3 bucket file. Now, if I go back to this folder and click on the output, this is the models that have. Based on these output artifacts, the next lessons we will deploy our trained model. So in the next lessons, we will continue. We will play around with these endpoints. So see you in the next video. Bye bye.